Hi, guys. This is Andrea. Jeff just finished up discussing the lack of preparation and participation in engineering to the degree that we would like to see. And one of the questions he posed was, what is going on in K through 12 that's sort of creating this? So the articles I'm going to be discussing as a follow-up to that are the math wars and the accommodation of a scientific conception toward a theory of conceptual change. I'm going to start out with just math wars, which really it just isn't a modern issue. This is something we've been dealing with. It goes back 100 years or more. But for the first part of this, really up until Sputnik, which we saw the video about earlier in the term, people were just complaining a lot. There wasn't a whole lot of change that was taking place. But we know that math has this power to enable individuals or entire groups to grow economically and socially. And that's why it's always been this point of contention. We want that for more people. So lots of conflict, not a whole lot done until Sputnik. So one of my questions that I'll end up posing at the end is, how do our current practices continue to propagate this elite-only mentality in math? What have you seen education do to discourage this? Maybe that's worked well. Or what do they need to continue to do to discourage this? All right, so new math, of course, we know occurred after Sputnik, and it really left a bad taste in the mouth of the public. It emphasized rigor, which was great, more demanding teaching methods, but these teachers were not prepared to do that. They didn't learn this way. They were not trained to do this. A lot of times they didn't know the content. So it wasn't supported. Parents didn't know how to help their children, and this curriculum became inaccessible. So when something's inaccessible, people either avoid it or modify it to fit their means, and then that usually negates all of the good things about it. This frustration ended up killing new math, and it really gave people a negative perception of reform. This was their first encounter with reform, and it didn't go well, and they became a little bit gun-shy after that. So in the 70s, we sort of transitioned to back to basics. Like, we don't want to do this new thing anymore. We want to get everybody basic concepts. But when we get into the 80s and we start assessing those students, what we really see is that, number one, they really can't problem solve, which is not really a shock because we weren't focused on that. But they also really aren't any better at the basics. Okay, so now we have another shift occurring. So we've gone from new math to back to basics. Now that's not working. What are we going to do now? So in 1980, the Agenda at Risk was released from NCTM, which is National Council of Teachers of Mathematics. And it just kind of stated that we know the focus only on basics is not okay. Now we need to also focus on problem solving. So again, this was not trained, not supported, and it led to a lot of trivial problem solving. Things like taking calculation-based problems and just creating a simple word problem. And that really didn't improve any of the problems that we had already seen. And at this time frame, we were going through another crisis as a country. This time it was more economic than military. We were seeing other nations start to take the lead, and that was not necessarily a good thing in the United States. And it sort of brought people into a state of fear again. So we have publication released that was the A Nation at Risk document. And in this document, it states that, this is happening to us because we have this rising tide of mediocrity. We're accepting this lowering of standards for our students. And that was published in 83. Right? Shortly after this, we have the results from the Second International Math Study, which also was poor. And, combined with that and the Nation at Risk work, this really, again, we've got public opinion very dissatisfied with what's going on. And now we have the introduction of politics. Okay, so once politics becomes involved, obviously this is a much more convoluted challenge now. One of the ideas that was kind of being floated by the National Science Foundation is this possibility for, curriculums we could adopt that would fix these issues. And they had the MACOS curriculum, which was Man, a Study Across Time, something along those lines. And apparently someone got a little piece of information about that and expanded that into be greatly conflictual. So at that time, people began to really rally against the idea of national curriculums. They wanted local control. And the thing about it is we've always argued that education is a states' rights issue, but at this point, that was really a facade. It was just something that made people feel better, but it wasn't reality. At that time, teaching was largely driven by textbooks, and textbooks were written to satisfy California, Texas, and New York. So if you were in Kentucky and you were using a textbook that was generated for California, essentially you're doing the same thing as California, although people didn't think about it that way. If you know a lot about the history of education in Kentucky, you know we have a pretty close relationship with repeating California reforms. So at this time, also cognitive science starts to become influential. So we start learning about how people learn, how they think, how they develop new contents and understanding. And that really, for the first time, started prompting real change. So when cognitive science started studying this poor performance in mathematics, they learned a few things. They learned that students were really inefficient at mathematics. They persisted in poor methods of problem solving. They lacked a wide range of tools, and they really just had no perseverance. If they couldn't solve a problem immediately, they really just decided it was too difficult and moved on. Okay, so we had another two works at this time sort of released, which was A Challenge of Numbers and Everyone Counts. Okay, these works were meant to define for us what our challenges were and how to make math an accessible curriculum for everyone so that everyone could have access to this upwardly mobile knowledge base. So at this time, the National Council of Teachers of Mathematics releases the standards document in 89. So, here they're really trying to just cover all their bases. They want to be vague because they don't want to continue to stir up this political controversy. And they have this vague version of just what it means to be mathematically literate. It's focused on content and assessment. And of course, because politics is still raging strong, there's immediate conflict on this. The idea among a lot of traditionalists were that if we made, people are not failing math because, it's just because math is hard. It's not because there's anything we can do about it. And if we're going to make it to where more people pass, then that means we're going to have to lower the rigor. And that was their idea. So that of course we know that's not true, but that was sort of the idea at the time. So because this document wasn't very specific, it also led to a lot of people sort of taking it and interpreting it in their own means, and they were applying it in some very inauthentic ways. And that led to some backlash. Okay. At this time, though, California decided to develop the mathematics framework, which was going to be sort of their own set of standards. And of course, more politics and more conflict. So there's a battle of opinions without data. I mean, we've had all these reform efforts, but it hasn't really been going on long enough to get data from the students, experience them. And I love this quote. I think it's still very relevant today. When things turn political, data doesn't matter. So, you've got this society that has just a very negative impression of reform for what they've gone through. And they really fear, that the next thing they do could, they know it's not working well now, but what I do next could be even worse. And that's unacceptable to them. So you've got some things that are really not happening well on both sides. You have your traditionalists that are just resistant to any change and they're disregarding research because it doesn't fit with their view. You have people without K-12 knowledge being able to have more weight in these decisions than people with K-12 knowledge. But the reformers also had their issues. They some really bad PR issues. They were not putting out necessary things and information and items for people to really understand what was going on in their ideas. So this just, of course, leads to some really uncivil rhetoric and a lot of public battles. But, eventually reformers got better at being thorough. And eventually we saw the National Council of Teachers of Mathematics release the principles and standards for school mathematics. And another question I'm going to end up posting here is, do we still have a PR problem with math? Why do people still view it as an unattainable thing to do and just a luxury only for those that are really, really smart? Okay. The last article that I looked into was about scientific conceptions. And I think this holds true, the information that's in here for science or math or really any kind of new understanding that we're trying to get students to make. Basically, this research was trying to understand Why misconceptions persist in students? Why are some misconceptions more prevalent, and why do they hang on even after students have been taught better? Okay, so they start out by defining learning as that being the result of just interaction between what you're taught, what you see and experience, and the current ideas and things you already know. Okay, it's rational, should be. It's concerned with ideas and evidence, like what do we see? What's the basis for this? And that's inquiry. We investigate things, we look for evidence, and doing so would lead to conceptual change or developing a new concept. Patterns in learning, they equated to research patterns in scientific theory development. We are either going to assimilate a new idea, which means we're going to make it match what's currently already in our thoughts, or we're going to have an accommodation, which is where we have to reorganize our knowledge because what we're seeing and experiencing no longer fits with what we already believe to be true. Okay. Learners, through inquiry, rely on our current concepts to organize what we do. So we use what we know already to plan how we're going to learn about something else. And what we see is either going to be logical based on what we know or not. It's going to be sort of an anomaly for that. And if it's not, what's going to push us from trying to assimilate it into developing a new understanding of how it might work? Okay. So we use our conceptual ecology. That's basically what's already hanging out in our head to determine if we're going to accept a new concept. We also use just our general views, analogies, metaphors, knowledge in other areas, and competing ideas to help kind of interpret this and make sense of it. In this particular research, the study focused on college physics. They were given a couple of prompts about theory of relativity, and they were asked to think out loud and explain their thinking for those. Now, I'm not a physicist, so I had to kind of struggle a little bit with some of the content through that. But what was really interesting is that in order to consider an alternative concept, students really have to understand these theories that they're talking about well. If they don't really have a working visual of what's going on, they don't even recognize when they have these illogical ideas or these anomalies, as it may be. And students have their own standards of whether or not they're going to accept a new concept. And a lot of times they don't match with scientists. The example that was given here was one student's idea of time being consistent. Okay. The more attached the students are of these own personally strongly held beliefs, the more likely that we're going to get assimilation. They're going to try to make it fit than accommodation, which is development of a new idea. Okay, so what prompts us to go beyond assimilation and start thinking in a different way? We've got to encounter dissatisfaction with existing views. In other words, there can't be a way to make it make sense. We have to understand why this weird thing happened. We have to understand why this doesn't make sense with what we already believe. And we have to want to resolve things when we have this conflict. Okay. And most likely also we're going to have, we've tried to assimilate, tried to make it fit with what we already believe, and that has failed. So this is it can be a gradual process for a lot of students. It doesn't happen all at once. It can be developed over time. So what implications does that have for teaching? Well, we have to make sure that students are aware of this process of learning and that they have a desire to have consistency among their scientific beliefs. And I would argue that to be the same among any content. There needs to be some standard of what is logical and what's reasonable in that topic. We have to create cognitive conflict in our students. They have to experience that through labs, lectures, experiences where they're asking, wait a minute, that doesn't seem like it makes sense. We have to take time to diagnose error in student thinking. Not every opinion is scientifically valid. And we have to identify defensive moves, like when we are speaking based on just those other thoughts and not necessarily on the true and authentic observation. We have to develop strategies to help students deal with these errors and defensive moves. Depending upon the culture that you're teaching in, that can be very different. We have to evaluate students in a way that tracks their conceptual growth. And we have to be Socratic tutors, prompting them to think in other ways and models of scientific thinking. If we're not doing that, then we're not giving them opportunities to develop these new ideas. So again, I will post the two questions along with the discussion, and Hopefully, we will be talking with everyone about this on our discussion board later.